Okay, we are now going to move on to solving equations using logarithms. Now, there's a couple of rules that we want to learn in order to be able to do this. The multiplication rule, the division rule, and the power rule. I'm going to go through each one by one, and I'm going to actually show you where they come from because I don't really like the idea of just giving you an equation and you just using it. I always like you to know where they've come from. So, I'm going to start off with the multiplication rule. And what I'm going to start off by doing is defining two logarithms, both of base a. So I'm going to say log of base a of x equals, let's do b, and log of base a of y equals c. Now what I'm going to do is I'm going to kind of get rid of the log and rewrite these both as exponents. So if we remember from previous videos, in both cases, we're going to have a as the base. In this case, we're going to have a to the power of b equals x. And in this case, down here, we're going to have a to the power of c equals y. And I've got these two. All I've done is I've just changed the form. These two statements are exactly the same, and so are these. Now, I'm going to multiply these together. I'm going to multiply x times y, which is going to be a to the b times by a to the c. And going back to our simple indice laws, a to the b times a to the c, we have the same base. So we are multiplying these so we can simply add the powers together. A to the b plus c. And this is equal to x, y. Now I want to apply my logarithms back to this equation. So let me just move this up. Actually, no, I won't. I will just do it under here. I've still got a bit of room. So I've got a to the b plus c equals x to the y. So I'm going to apply a log of base a to both sides. So log of base a of a to the b plus c is equal to the log of base a of x times y. Now, over here, I've got log of a and an a. They're going to cancel, and I'm going to be left with b plus c equals log base a xy. And, well, b plus c, this is b, and this is c. So, b is this, log base a of x. C is this, log base a of y, and that is equal to log base a of xy. And this is our multiplication rule. If we have two logs with the same base, and only if they have the same base, it's a bit like a surd. You can combine surds if they have the same base, I suppose. It's all the same thing, actually. Surds are also just exponents, but, you know, that's a different problem. Log of base a x plus log of base a y. This x and y combine into a multiplier to get xy. Now I'm going to very quickly do the same thing to get a division law. So basically I'm going to rush through this because it's the same process as last time. I'm going to rewrite these as a to the b equals x and a to the c equals y. This time I'm going to divide them. I'm going to do a to the b divided by a to the c, which is x divided by y. Because these are the same exponents, I can, instead of adding them, the same bases, instead of adding the powers, I'm dividing so I can take them away. This is a to the b minus c equals x over y. Apply logs to both sides. Log a to the b minus c equals log a x over y. log a cancels with its own base, b minus c, log a x over y, just still doing the same thing I did last time, just with dividing and a minus in there, and then replacing my b and my c, as I did earlier, up here, I get that log a x divided by, minus log a y is equal to log a x divided by y. And this is the division rule. And finally, I'm going to prove the power rule, which is one that people often forget or don't really know when to use. Let's have a look. The power rule can be proved. I'm going to use the same notation as before. Log base a of x equals b. I don't need another one this time. Once again, I'm going to rewrite this as a to the b equals x. And now, instead of multiplying or dividing by anything else, I'm going to raise both sides to the same power. Let's say n. So, a to the b to the n and x to the n, which is going to give us a to the b to the n, sounds like a beach, a to the b to the, no, a to the b to the n, one base, two powers applying to each other, so the powers will multiply together. We will get abn equals xn. Once again, I'm going to apply my log of base a to both sides. So I'm going to get log base a to the bn. Remember, I can apply this log whenever I want. Equals log base a x to the n. Log of base a cancels with its base. So I get bn equals log base a x to the n. Now I'm going to replace my b with this b. So this b here becomes a different colour. I'm going to close all these so my nice white shirt doesn't get tarnished. I'm going to end up with log base a x, which is b, times by n, which is log base a of x to the n. And just by inspecting these, I have log base a x all times by n, so I'm actually going to put that n out in front just so it's a little bit clearer to see. Everything is multiplied by this n, is equal to log base a x to the n. Just by visualizing it, this n here has moved in front of my log. Just to write that out properly, log base a x to the n, this n has moved down here. And these are the same thing. So whenever you are working with a logarithm and you have something within the logarithm to a power, pull that power down. If we had, just very quickly, if we had log of root x, always be thinking, what can I do to simplify this? Well, this is the same as log of x to the half, and I know I can bring that half in front, and I get half log x, which is much simpler to work with. So always be on the lookout for when we can get some exponents involved. If there's a root, or if there's maybe, I will rub this out again, another quite common one would be log 1 over x. Well, again, ask yourself, is there anything I can do here? Well, it's a divisor, so you could use the division rule. It'll give you the same result. Or I could say that this is the same as log x to the minus 1, because 1 over something is that to the minus 1. And I can get my minus 1, bring it down in front, and I end up with minus log of x. Incidentally, kind of going off on a couple of tangents here, if I applied my division rule, I would get the exact same thing here. which I'll quickly do. 1 divided by x, meaning it is the same as log of 1 minus log of x. That's our division rule from earlier. And if you put log of 1 into your calculator, it is 0. So we're just left with minus log of